All right, hi, Ms. Dren. So I'm going to talk through this test. I did take a terrible picture of the last page, so I won't be able to go over the last page with you, but I think going over all this will help you with this, okay? So this first problem you did awesome on, so remember, if we're just given two sides and it's a right triangle, we're going to do Pythagorean Theorem. So 8 squared plus 7 squared equals c squared. This would be 64 plus 49 equals c squared. And I don't have a nice calculator near me, but we can get one. So that's going to be 303. And then we'll square root both sides. And magically life should be good there. Let me pull out my Desmos calculator. Okay, equals c squared, and then we'll go ahead and square root both sides and do our stuff. Hold on. And that's all we would have to do for that one. For this next one, you did the same thing. We had a right triangle, and they give you the hypotenuse, which is always our c value, remember. Sorry, I'm trying to do two things at once, and that's just not a good thing. Plus 64. Let's just make sure my math is right. Oh, this would be 113. Sorry, can't add 113 because we got to carry the one. And square root of 113 we can just leave alone because there's no buddies to break it down. But here you did beautifully. You set it up, and you were like, okay, I know all these numbers, and you subtracted over. You just need to be careful of your buddies. So you broke down your buddies, and you're looking for pairs. Okay, so you did here. You broke these down into 2 and 2, which is awesome. So you have a set of 2. A set of 2, a set of 2, and a set of 3, because 3 times 3 is that, okay? And so 2 times 2 times 2 times 3, and there's nothing left over that didn't have any buddies, because all of these numbers have been broken down. 2 times 2 is 4, times 2 is 8, times 3 is 24. So the square root of 576 is 24. So go ahead and make sure you check in the calculator that it's not a perfect square root before you actually do all of this breaking down stuff, because your calculator can just tell you that part, okay? So just make sure that it's logical, okay, instead. This is not a Pythagorean, so this is a Pythagorean triple because a squared plus b squared equals c squared. So 10, 24, and 26 would be a Pythagorean triple because it works with this formula, okay? All right. So let's keep going here. This one, whenever it says right is simplified radicals, you need to use a special right triangle, okay? So with a 45-45, all you need to remember is the hypotenuse has a square root of 2 with it, okay? The two sides, the two legs are both the same, and then whatever those legs are, we multiply by the square root of 2, okay? So we know the hypotenuse is equal to x square roots of 2. So we are going to set that up as a problem because it wants to know the side length. So we're going to have 12 square roots of 3 equals x times the square root of 2. To get x by itself, we have to divide by the square root of 2. Now remember, we don't like to have square roots in the denominator. So we're going to rationalize the denominator. So in order to get a square root of 2 by itself, we need to multiply by a square root of 2. And whatever I do to the bottom, I must do to the top. Well, square roots we can just multiply inside. And since 3 and 2 aren't going to give us a buddy, we're just going to leave it as 12 square roots of 6. Okay? Well, the square root of 2 times the square root of 2, you could even type that in the calculator, it's just 2. Okay? Now, because there's numbers on the outside, 12 and 2, we can just simplify them because there's no adding or subtracting signs. So this is 6 square roots of 6. Okay? So the biggest thing is remembering this formula. So even if this is the only one you remember, I think that will help you a lot to do better on this test. 45-degree angles, x and x, square root of 2. Okay? So you just really need to remember a 45, the hypotenuse has a square root of 2 with it, and an x with all three sides. Okay? Moving on here, so it says, what are the values of HIJK, and we know 12 square roots of 2. So again, this is a special right triangle again, so if you want to try and remember this one, the 30 goes with x, it's across from x, okay? X square roots of 3 is across from 60, so remember the 3 touches the 30-degree angle, so 3 and 3 go together, and the other two legs both have an x. And then this one is 2x. So think okay, double 60, 30 is double that, you get 60. And the 2x goes between the 30 and the 60. Okay, so hopefully that'll help you kind of remember it. So it says we want to know the value of KH and HI. So we need to find this side and this side separately. So I need to first figure out what x is, okay? So this 12 square roots of 2 is actually equal to x square roots of 3. On the quiz, if you can draw this fast before you do anything, that will help you a lot. Again, we're going to divide by the square root of 3, just like what we did in the last problem. In order to rationalize the denominator, we're going to multiply top and bottom by square root of 3. So whatever number is in this radical, we're going to go ahead and multiply by that same exact square root, okay? So again, 2 and 3, there's nobody, so that's going to be 12 square roots of 6. Square root of 3 times the square root of 3 is 3. And I can reduce this to make my life easier. The 12 and 3 reduces to 4 square roots of 6. And that's what x equals. So that's what this side is 12 square roots of 6. I'm sorry, 4 square roots of 6. I can't right here. So this is 4 square roots of 6 because that's what x equals. Now that we know what x equals, we can figure out what 2x is. Well, all I have to do is 2 times 4, which is 8, and then keep the square roots of 6, okay? You don't have to multiply that 2 inside because it's not under a radical, so we can't do that, okay? So again, I found the side that matched. I set it equal to the side that goes with it, and I solved for x. Once I know x, I know that side length, and then I just double it for this one, okay? And again, how I remembered it, the 30 is touching x square roots of 3. Opposite of 30 is x, and because 30 is half of 60, or double to get 60, I do 2 times x. Okay, so I would say this one's probably going to be your hardest one because you have to memorize another formula. So if you can just remember the first formula, x square roots of 2, then you can kind of just ignore this problem, because even if you lose 4 points, it's still better than your other score. Okay, so find the value of x. You can tell Mr. Dorr he wrote a y here instead of a u. Just kidding, don't tell him that. And round to the nearest hundredths place. So this is where Sohcahtoa comes into play. I have an angle and I have a side, okay? And what I would do is I would look at my angle, whatever angle, if I need to find an angle or if I'm given an angle, and label, be like, okay, this is opposite, this one is adjacent, this one is hypotenuse, and maybe even labeling the hypotenuse first, okay? And then I'm like, okay, I have O and A. What does O and A go with? Okay, I have Sohcahtoa. Oops, if I write correctly, sorry. That's an H there. Toa. So I have O and A, so that means I have tan. So I have tan of the angle. I know the angle is 20. Equals opposite, which was my x, over my 6. And I'm going to multiply both sides by 6. And you can just go ahead and type that into a calculator. 6 times the tan of 20. And let me bring up my calculator. So 6 tan of 20. On parenthesis, enter, is 2.18, I'm sorry, which near this hundredth, yeah, 2.18, okay? Same thing here. So again, I might always find my hypotenuse first. We know that's across from 90, that's a hypotenuse. But the angle 28, this is opposite, this is adjacent. So I know my adjacent, and I want to find my hypotenuse. So what goes with H and A? And that's cosine. So I have cosine of my angle equals adjacent 13 over x. Okay. Remember the shorthand, if x is on the bottom, we can just switch the cosine or sine or tan, whatever it is, and x. So we get x equals 13 divided by cosine of 28. And I'll go ahead and divide that in the calculator. 13 divided by cosine of 28. And that would be 14.72. Make sure you're rounding to 2 decimal places if he says nearest hundredth, because we don't want to lose a half a point just because we're not rounding correctly. Okay. All right, find the value of x. Again, so this one, again, we have an angle. We know this is our hypotenuse. We know this is our opposite, and this is our adjacent. Label it, okay? So I know I have my adjacent and hypotenuse, which means it's cosine of the angle, which is x in this case, is 6 over 10. Okay, adjacent over hypotenuse. To get rid of a cosine, I do cosine inverse. Okay, so I'm going to cosine inverse this side. And if I do that, cosine inverse of 6 divided by 10, I can type that right in the calculator. Oops. And that's going to be 53 it says nearest tenth of a degree, 53.1 degrees. Okay, so no matter what, if we have a right triangle and we have 2 sides or an angle on a side, we can use sine, cosine, tangent. Okay. If it says to the nearest degree or whatever, then use that. If it does say radical form, that's when you want to use the special triangles, even though technically you can use sine, cosine, tangent to find it. They just don't give you the angle, okay? All right, Mr. Collins' class uses a survey measuring device to find an angle from their location to the top of the building. They also measure the distance from the bottom of the building. The diagram shows the angle and distance. To the nearest tenth of a foot, find the height of the building. So our goal is to find this wonderfulness, okay? Again, I know that this is my hypotenuse because it's across from 90. Because this is my angle, this is my opposite, this is my adjacent. And the opposite is what I'm trying to figure out. So opposite and adjacent goes with tan of 72 equals opposite x over 100. So I'm going to multiply both sides by 100. So I'm going to have 100, whoops, a daisies, 100 times tan of 72, which is going to give us 307 point, what does it say, round to? Round to the nearest tenth of a foot, so that would be 7.8. Okay, so one, watch your rounding, make sure that's okay, and make sure your answer makes sense. It makes sense for the building to be 307 feet tall, right? If it was less than that, we would have a much shorter elevation, okay? All right, let's look at this one. Again, we have an angle this time, so we don't have to use our special right triangles. And see how it says round to the nearest hundred? So if it's saying like hundredths or tenths or whatever, that's when we can use sine, cosine, tangent. It's when it says radical form that we have to use those special right triangles. So again, this is my hypotenuse because it's across from 90. My x is opposite of this one and adjacent to this one. So I'm going to have an opposite over hypotenuse, which is sine of x equals 3 over the square root of 58. Again, we undo sine by doing sine inverse. Okay, so I'm going to do sine inverse of 3 divided by the square root of 58. Which is 23 point, we need to round to the nearest hundredth, which would be 20 because there's a 9, an 8 after the 9. So that makes it that, all right? And I'm sorry, I really can't read this. I think you're just finding all of your different side lengths, so you're going to use your sine, cosine, tangent to solve each of the pieces that you need to find, okay? And I just really botched that picture. Apparently I just moved too fast. So if you want to send me a picture of it, I can maybe do a quick video for you, but let me know. Have a great day. Bye.